Today we're going to be going over whole numbers and place value. Our whole numbers are just another word for, or you can refer to them as our counting numbers. So as we learned in primary school and intermediate, that is starting from 0, going up 1, 2, 3, 4, you know the rest. But the cool thing about the set of numbers is that it is infinite, which is a very important word in mathematics. It just means it goes on forever. So for example, if you were to give me a very big number, the biggest number you could think of, I could add 1 to that, and that would be a bigger number than you gave me, right? And you can keep on doing that forever and ever and ever, and so that's what makes it infinite. But I'm sure, as you know, that these whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, 8, so on, can be written either as numerals, which is how we've written them here, or we can write them as words. And this might sound very straightforward, but there is definitely a lot of importance in being able to write these as words and represent them as the way that numbers are presented to us in our modern world. And that's a really important basic to go over, as simple as some may find. So for example, 6, 7, 1, we recognize this as, well, there's 6 hundreds, there's 7 tens, and there's 1 1. So we write this as 671. But how did we get here? Why are we putting the and here? Why don't we just say 671? Why don't we just say 671? That kind of thing, right? So some mathematician a while ago and putting together math and numbers kind of figured, well, let's put a system together for this. And the way that we talk about numbers today, we kind of put our place values, as they're called, into nests of 3. So place values go into nests of 3. And what do I mean by that? Well, suppose I was to give you the number, and I'm not going to say it how I normally would. Suppose I was to give you the number 920 678 152. Now, we know that's a big number, but how do we communicate that effectively? Well, we can put it into groups. A bit like this. Just like that. Put a table together. And this can be really helpful in some of the exercises that we might be looking at today. So these are our millions, our thousands, and our ones. Or you can call them your units if you want to. Units sounds a bit more fancy, so some people might prefer to call them units. And then we can actually break down these into their own 3 as well. Their own groups of 3. Here we go. Just like that. Okay, well, that's great, but what now? Well, now we can put our number in, and I would recommend starting from right, going to left. So we've got 2 here, we've got 5, we've got 1, we've got 8, 7, 6, and we've got 0, 2, 9. Now, if I just isolate temporarily, or if I just put by itself 920, right? We know how to read that. That's 920, just like as I was going over with 671 before. But the thing is, it gets a bit more complicated sometimes when the number gets bigger. So how do we word it? Well, 920 million 678,152. And with the 152 part, we don't add anything onto that because that's just our ones. That's what's left over, right? So 920,678,152. And that's all. That's how we represent it as in numerical, not numerical form, but in written form, or spoken form, rather. So as you can see, these are now nests of 1, 2, 3, and that's how we can communicate that a bit more effectively. So what if we were to say, what if I was to give us another number, like 1, 5, 8, 7, 4, 5, 3. Okay, let's put that into our table. So I've got 3, 5, 4, 7, 8, 5, and 1. We don't have anything here or here, do we? So we're just going to leave those open. We don't need to put anything in those. So what we've got now is we've got 1,587,453. And we don't add anything onto that one. Okay, that's great. Now we know how to say that verbally. So what if I was to ask us, what is the value of the digit 7 in this, right? Now, what we can also do here is I'm going to add a little bit extra onto our table here. I'm going to put an H, I'm going to put a T, I'm going to put an O. Now this might look confusing to start with, but keep in mind when we were doing our 920 million piece over here, we were 920 because 20 is a 10, and there's no ones, yeah? In this case, there's 1, 1, 1 million, 900 million, 920 million. So in this case, we can do this to all the other parts as well. So in this case, this 1 here represents 1 million, right? This 5 here represents 500,000. This 8 represents 80,000. The 7 here represents 1,000. The 4 represents 400. The 5 represents 50, sorry. And the 3 represents just 3. 3 ones. 3 ones are 3, as you might recall from your times tables. So if we want to find out what 7 is, what 7 represents in our number, it can be really helpful to put it into a table like this and determine, oh, well, I need to just go to our 7, look at what category it's in, and look what it's assigned to. Oh, 7,000. The 7 in the number 1,587,453 represents 7,000. So what if I was to ask what the value of each digit in the number 537,246 was? So if I wanted to find out what the value of each digit is there, I'm going to put it into a table. So let's start with 6, 4, 2, 7, 3, 5. Look at that, we've got a 5 and a 7 in the same place as last time. So let's count it out. That's 537,246. Yep, that's kind of the case where we can sort of get rid of the and between them. We don't say 537,000 and 246. We can often get away with just saying 537,246. Which could be a bit confusing, but I'm sure no one will mind if you put an and in there. So what we can do now is we can determine, well, this 5 is in the hundreds column in the thousands nest, as we call it. So let's say the 5 represents 500,000. The 3 represents 30,000 because there's 10 of them in the thousands. And the 7 is just 7,000, very similar to the one we just did before. Now the 2 just represents 200. The 4 represents 40. And the 6 represents just 6. There's just 6 in there. Awesome. So going on from that a bit, we can kind of expand numbers or compact them or compress. So those are some keywords we're going to be using here at the moment. So what do I mean by this? So if we had the number 8,345,908, and we wanted to write it in expanded form. So we know that 8, if we can put it back in our table to make ourselves a bit more comfortable. Let's go back to front again. So we're going to put the 8, the 0, the 9, then the 5, the 4, and the 3, and then the 8. So we've got 8 millions, we've got 300 thousands, we've got 40 thousands, we've got 5 thousands, we've got 900s, we've got no tens, and we've got 8 ones. So in this case, if we've got 8 millions, what does that mean? Well, if we have, for example, if we have 8 fives, that makes 40, right? We're doing 8 times 5 is 40. So in this case, if we have 8 millions, then we're going to do 8 times 1 million, just like that. Now I've put in my notation is a little bit inconsistent here. Here I've put some commas to differentiate or to help us identify the difference in the nests. For example, this is the ones nest, this is the thousands nest, this is the millions nest, or part of it. But honestly, either way you do it is completely fine, as long as you're consistent, unlike what I've done. So just because of that, I'm actually going to get rid of my commas there, just to make sure that I'm doing it consistently. So then I'm actually going to add on 3 times 100,000, right? Because as we agree, we've got 300,000. Then we're going to do plus 4 times 10,000. Then we're going to do 5 times 1,000. And then we're going to do 9 times 100. And then we don't have any tens, right? So we can actually just do 0 times 10. And then I'm kind of running out of space here, so I'm just going to put the next one down here. Just think of this as like one line going on. Then we've got 8 ones. So 8 times 1. Okay, so this is 8,345,908 in expanded form, as you will. So that can kind of help us just get a better idea of what we're looking at and how big this number really is. Because 8 million is a very big number in some cases. So what if we wanted to do it the other way around? What if we had a number like 76,000? I'm just going to draw a line here so we don't get confused. What if we had a number like 76,013? Okay, bit of a weird number. How would we write that in expanded form? So we could probably write that like 7 times 10,000 plus 6 times 1,000. And again, look at that. I'm continuing to add my commas. So let me just get rid of those. Seems to be a natural habit of mine. But it'll let me erase it. There we go. 6 times 1,000 plus 0 times 100, right? Because we don't have any hundreds here. And then we've got 1 times 10, which is just 10 between you and me. And then we've got 3 times 1, which is 3. So do you see how we've got 1, we've got 10, we've got 100, we've got 1,000, we've got 10,000. I'm just adding on a 0 to each one to represent a different place value in our number. What if we were to convert from expanded like this to compact like this? So if we had, for example, 1 times 100 plus 3 times 10 plus 6 times 1. Well, we can always go backwards, but let's evaluate this first. What I mean by evaluate is let's solve each piece step by step. So 1 times 100, we know that's 100. What's 3 times 10? That's 30. And what about 6 times 1? That's just 6. So 100 plus 30 plus 6, that's a fairly easy sum. So we know that's 136. And there we go. So the compact form of this number is 136, but the expanded form of it is 1 times 100 plus 3 times 10 plus 6 times 1. That's not too bad, right? Okay, I'm going to drop some exercises in here for us to work through, and I'll be right back. All right, we're back. So let's have a look at what we're dealing with here. So we want to, our first question is to convert numbers to words. So I'm actually going to change the color of our pen here to blue because I think that's nice to do our questions in. And I'm going to maybe make another page. I try to remember what we put down here. So a table is going to be really useful to us here. So we might actually approach all our questions like this because we're dealing with, place value questions. So let's do this. We've got millions here, and we've got our thousands, and we've got our ones. I was going to put tens there, but that isn't quite right. And I'm going to put our 3 mini groups down the middle. Got a good tool that helps me make my awfully non-straight lines very nice and orderly. Even then, though, there's some weird angles going on there, but it's much better than, making a line like that, right? Okay, so let's make another row down here just to help us make this look a bit nicer. So I'm going to put HT0 for hundreds, tens, and ones, and follow that along in each of our nests, as we've called them. So let's have a look. We want to convert 145,867,987. So if you find a number that hasn't really been put into nice, hasn't really been put into like nice, that hasn't really been put into nice nests like this with 3 numbers in each nest, then you can always go from the rightmost number and move backward, okay, in 3s. That'll help you out a bit. So let's have a look here. We've got 987 in that latest nest, or in the rightmost nest. In the middle nest, we have 867. And in our millions, we have 145. Okay, let's try and say this as a word then. So we have 145 million. Yeah, 145 million. We've got 867,987. So 145 million. You can put a comma here. 867,987. Okay, that's the answer to the first one. Let's try and do words to numbers now. So we want to try and turn 30,908 into a numeral or a number. Same thing, numeral, number, interchangeable. So 30,908. So we see that we have 30,000 here. So that's a really good giveaway to us, but that's going to belong in our middle nest. So we're going to have 30,000. See how I put the 3 and the 0 next to each other like I would with 30? I'm just putting that in our thousands nest to help us represent 30,000. What do we have left after that? We have 908. So it looks like we've got 30908. So that's our answer. Okay. Okay, now we want to put this next one into expanded form. Now this one looks quite tricky because it looks like we're missing some numbers, right? Looks like we're going to have 0 times of something. So what we can do here is we can put that again into our table here. So we've got 9004 or 9004. Let's put those in. Okay, so it looks like we've got 9,000, we've got 0 hundreds, we've got 0 tens, and 4 ones. So 9 times 1,000, right? Because we have 9 thousands. And we're going to do a plus sign, not a comma, that was my bad. Plus 0 times 100, plus 0 times 10, plus 4 times 1. So we can actually go a bit further than that because we know that this one and this one are gonna disappear, right? Because 0 times anything is gonna give us 0 back. Now, I only want to do this with zeros, okay? Because otherwise we're just going to end up back to our compact form. So I'm actually going to simplify this a little bit, make this a bit more simple for us. So 9 times 1,000 plus 4 times 1. And I bet you're going to get extra marks for that. Because having the zeros in here doesn't really give us any meaningful information. It's just saying, well, that doesn't give us anything, so we're just not going to put it in because this gives us the same answer. Okay, let's do some largest to smallest. So we've got 7691. I'm going to put a line here just so we know we're moving on. 7891. We've got 8761. And we've got 8791. So the way we can get around ordering these in terms of their size from largest to smallest is by looking at each mini nest or mini group, as I think I called them. So for starters, we know that we know that 8 is bigger than 7. So this one of these two is going to be bigger than these two, right? No matter what. 8 is always going to be bigger than 7, regardless of what comes after the 7. So what comes after our 8s? Oh, they're both 7. So we're going to look at the one after that. What comes after this one? It's a 9. So we know that this one here is going to be bigger than this one. So we've got the first part of our order. So what comes next? Oh, well, we can choose between 7, 7, and 8. So this one is going to be next. Okay, now we need to decide between these two. These are both 7, so we can't really judge which one is bigger just based on our thousands column. However, if we go over to our hundreds column, we notice that 8 is here when 6 is here. And we know that 8 is bigger than 6, so we're going to put this one is bigger than this one. Okay, so you kind of just go down the list and see, see if there's any problems that come up. So in our case, we've come across a problem where we're comparing these two numbers and the next place value is bigger than this one. So we're going to have 7891 and 7691. So no, I'm just going to copy paste that because I'm feeling lazy today. But you can put it in your books if you like. You can write it out, completely up to you. I know that your teacher would greatly appreciate you putting all of your working onto paper. All right, let's try and determine our value of 6 here. And let's try and go a bit outside of our comfort zone. Let's try and figure out what the value of 6 is without using our magic table. So we've got 2,436. So we know we have 2,000, we know we have 400s, we know we have 3 10s, and we know we have 6 1s. So the answer to that is just 6. That's all she wrote. Then we've got 600s, we've got 0 10s, we've got 5 1s. Don't forget, I did say we've got 600s, right? So we have 600 there. That's what the 6 represents. We've got 600. Now, if it helps you, we can actually put this out into expanded form and see what 6 is associated with there, what 6 goes with. What I mean by that is if we were to expand 605, then we would be looking at something like, 6 times 100 plus 0 times 10 plus 5 times 1. So because 6 is what we're looking at, we see that 6 times 100 is here, and that's our goal. That's what we wanted to find. 6 times 100, we know that's 600, so that's the value that we're looking for. What about in this one? We've got 12,000, because if we separate this one into its own nest, we've got 12,865. Don't forget, I said 60, so this one represents 60. Now what about this one? I know it's a big number, but I promise it's not too bad. We've got 6,521,437. Okay? So don't forget, I did say 6 million at the start. So that's exactly what that's going to be. That's what that 6 represents. So now we want to write the number in words. That is 7 more than 7,365. Now let's think about this carefully. Now we know that we can actually break this this sentence down because we know that after the 1,000, a new nest starts, right? See how 365 is here, and then the thousands come to the left of that, much like this one and this one. The thousands come to the left of the hundreds or the ones. In our case, we've got 7,365. I almost wrote another comma there. Right? Now we want to add 7 to that. So if all you math whizzes out there will know that that plus 7 is, oh man, my arithmetic or my adding isn't doing very well today. That's going to be 7,372. Okay. We can break that down a bit for ourselves and just put a little nest there so that we know that the 7 comes before it. So we know that this is 1,000 or 7,000, then 372. What about 604? We know that we have 600s, and we have 4 ones. How many 10s do we have? It doesn't mention. We're just saying it's got 600 and there's 4 more. So we don't have any 10s. Then we want to add 7 to that. So we're going to have 611 from that. 611. And I would encourage you to write these in words as well, because that can be really helpful. Although I am running out of space a little bit here. Then we've got 11,009. So we've got 11,009. So we don't have any hundreds, we don't have any tens, but we do have a 9. Then we're going to add 7 to that, which is going to give us, if we temporarily get rid of our 11,000 here, if we temporarily just get rid of that and ignore it for a second, what's 9 plus 7? We know that's 16, so we still have our 11,000 there, but there's going to be 16 there at the end. So 11,016, because we don't have any hundreds. And that's about all. That wasn't too bad. Like I said, it's probably fairly simple stuff, but it is a very, very important process to really understand before we get much more into math. Because otherwise, if you don't know how to break down a number and you don't know how to communicate it, then that can cause problems. So I hope this was a help to you. But in any case, best of luck with your maths. I believe next time I'm going to be going over some addition and subtraction strategies. And interestingly enough, I'm already seeing from my notes here that we've got some very important bits and pieces going on there.